Hello students, I am Saili Rathod. I welcome you all in a new video of digital electronics. The subject code is 204 and this is the third video of the lecture series in which we are going to cover the hexadecimal number system and the octal number system. The topic covered today is of the first unit, that is the number systems. So, what we have seen in the previous lecture is the different types of number systems we have seen in the previous lectures, and today we are going to see the hexadecimal and octal number system. Okay, so let us start with the today's topic. Before moving to the new topic, we will have an overlook that we have studied in the previous lecture, in which we have covered introduction to number system. We have seen that what is actually a number system and why there is a need of number system. Then we have covered the topic binary number system. So we will just have an overview. What is binary number system? As from the name itself, it tells us that it uses bi, means two types of numbers, digits, to denote the number system. So it is called as the binary number system, which uses 0 and 1 for the representation. Then the next point we have covered is signed binary number system. Signed binary number system is what? As we know, in general numbering systems, we use positive and negative sign in front of any number. So in the same way, for the binary number system, we also use a 0 or 1 to represent the positive and negativity of that number system. So this was the signed binary number system. Then we have seen the binary arithmetic. Actually, we have to see this binary arithmetic in detail after studying all the four number systems. So we have just only had an examples of the arithmetics while studying the binary and the decimal number system. And the next point we have covered is decimal number system. Decimal number system is what? The number system in which we use the digits 0 to 9 to represent a number. That number system is called as the decimal number system. So these points we have covered in the previous lecture. And the today's topics are hexadecimal number system and the octal number system. So just tell me what is the hexadecimal number system? Means the name itself indicates that it is a hex, means 16. It uses 16 types of digits to represent the number system, and the octal number system, which uses 8 types of digits to represent the number system. Okay. So next is decimal number system and binary number system. We have shown here one examples to just had an overlook of the system. So example of decimal number system is 30.2 to the base 10. Okay, so this is base. In the previous lecture we have also studied the base or radix. So in the example 30.2 we have the base 10. Okay, so what is meant by base or radix? It is the number of digits used for representing the number system. Like in decimal we use 0 to 9, means 10 digits, therefore the base is 10. In binary number system we use 0 and 1, two types of digits to represent the numbering system, therefore it is called as the binary number system. Now in this example, first example of decimal number system, how we can represent it? Like first of all, 3 into 10 raised to the power 1. Sorry, here we should write only 3. 3 into 10 raised to the power 1 plus second digit is 0. Therefore 0 into 10 raised to the power 0 Now after the decimal point, the next digit is 2. So 2 into 10 raised to the power, we have used -1, because after the decimal point the base goes on decreasing, means -1 into 10 raised to the power -2 and so on. And the second example here given is 212.367 to the base 10. This is also a decimal number to which we can represent as when first 2 into 10 raised to the power 2. Then second digit is 1. So 1 into 10 raised to the power 1. Third digit is 2. So 2 into 10 raised to the power 0. And after decimal point the base goes on decreasing. So 3 into 10 raised to the power -1. And after that 6 into 10 raised to the power -2. And last digit is 7. So 7 into 10 raised to the power -3. So this is all about the decimal number system. We have studied in the previous lecture. The next point is binary numbering system, in which we use 0 and 1 for representation. When we represent 0 in the binary code, then we put 0 at all the 4 places, 8, 4, 2 and 1. Now when we represent 1, the place of 1 okay, the place of 1 we put 1 and others are 0. 2 is represented as 0 0 1 0. 3, decimal number 3 is represented at 0 0 1 1. Then decimal number 4 is represented as 0 1 0 0. Decimal number 5 is represented as 0 1 0 1. Decimal number 6 is represented as 0 1 1 0. 7 as 0 1 1 1. 8 as 1 0 0 and 9 as 1 0 0 1. Okay, so this is the decimal number system. Now the today's point, that is octal number system. As from the name itself we can say we are using here the numbers from 0 to 7. What we are using here? The digits from 0 to 7. So the octal number system, or oct, is the base 8 number system. Means the base of this number system is 8. And it uses the digits from 0 to 7. For an example, 10 is represented as 8 in decimal. Okay, and the 100 represents 64 in decimal number system. So how we can represent 10 in 8, this we will see in the next slide. Okay, so in general we use a base 10 number language system. Hence a true octal system might use different language to avoid confusion with the decimal system. Now here there are example of octal number system. Here you can get the clear idea about the octal number system. First example, here the question is convert the octal number 121 to the base 8. Means why 8? This is the base. It is not shown like a base, but 121 to the base 8 to its decimal form. Means we have to convert the octal number 121 into its decimal form. So here the solution is given 121 octal number. How we can represent it? We have to first write the first digit of that octal number system, that is 8. Then 1 into 8 raised to the power 2. As this is octal number system, we have to use base 8. Therefore, we have multiplied the digit 1 by 8 and the power of 8 is 2. Why 2? Because the octal number is of 3 digits. So, we will need the powers as 2, 1 and 0. So, the first digit will have the power of 8 as 2 plus the second digit of this number, that is 2 into base is what, 8, and the power of 8 should be 1. Now the third digit of this octal number is 1. So we will write 1 into 8 raised to the power 0, as this is the last digit of the octal number. So the power of 8 is 0. Now again, how we can represent the same in the form of 1 into 64. 8 square is 64 plus 2 into 8 plus 1 into 1. 8 raised to the power 0 is 1. Anything raised to the power 0 is 1. It means it is equals to 64 plus 16 plus 1. When we will add all this, we will get 81. So the resulting conversion is 81. And what is this? This is a decimal number. So it is having the base 10. So this is the example of octal number. Now, what is the difference between the decimal and octal number system? See, in decimal number system, the base is 10. Means in place of 8, we use 10 in the decimal number system. And in octal, we use the base as 8. Okay. All the converting techniques are same. So moving to the next slide. This is the hexadecimal number system. Now the hexadecimal number system is described as a 16-digit number representation of a number from which uses 0 to 9 and the digits from A to F. Okay, so we use 16 types of digits for the representation of hexadecimal number. Which 16 types? Here in the last row of the slide, we have written all the terms that we use for the hexadecimal number system. In decimal, when we write 0, hexadecimal also it is 0. Means for hexadecimal, we use the numbers from 0 to 9. Here we can see the numbers from 0 to 9 and the alphabets from A to F. Okay. So while we calculate the hexadecimal number system, or we convert this in another form, sometimes we will have A. So how we can write A? We can count it as 10. When we write B, we can count it as 11. Okay, so that we will see while calculating or converting into next another number system. Here some examples are given. First example of hexadecimal number is 7B316. This is a hexadecimal number. So any hexadecimal number can include the alphabets from A to F, and also it can include 0 to 9. Second example is 6F16. Third example is 4B2A16 and 6F16. Okay. So this is the hexadecimal number system. Here in the last example, 6F16. So we cannot consider it as 16. It is not 16. It is decimal number 1 and decimal number 6. Clear? So this is the hexadecimal number system. Here we have shown an example of hexadecimal number system. Convert hexadecimal 76. It is repeated, I guess. Okay. So 76 to the base 16. This is an hexadecimal number and we have to convert it into binary. So the solution to that, this is also repeated here. We have to convert 76 hexadecimal number to decimal. Okay. So how we can solve it? 76 to the base 16, means we have to multiply every digit of that hexadecimal number by the base of 16, and the power of that 16 should be decreasing from 1 to 0. So in the first line we can see first digit is 7 into base is 16. So 16 raised to the power 1. Why 1? Because the hexadecimal number, it is of 2 digits. So the power of first 16 is 1 and the power of second base, that is 16, is 0. So 7 into 16 raised to the power 1 plus 6 into 16 raised to the power 0. Okay, so this can be also written as 7 into 16 plus 6 into 1. So 16 into 7 is 112 and 16 into 1 is 6 into 1 is 6. So 112 plus 6, that is 118. So here we have converted the 76 hexadecimal into 118 decimal number. So this is the final conversion. Okay, so in this lecture we have seen the hexadecimal number system and the octal number system, and we have also seen the representation of hexadecimal and the octal number system. So in the next lecture, video lecture, we will meet with a new topic of digital electronics. So till that, thank you and keep studying.